Welcome to episode 21 of the Building Interactive website series, where we'll learn how to use loops in JavaScript. So the reason why we need loops is because loops help us repeat statements for a given or unknown number of times. And without loops, we need to execute the same statement multiple times, as in copy and paste the same statement on many times over, which takes up a lot of space in our code. It doesn't look very neat. It's also much harder to maintain over the long term. So let's look at how to actually start coding loops now. Now we already know about the for of loop to iterate through each of an array's items, and this kind of for loop where you're iterating through all the indexes of an array by using array.length. But this kind of for loop is what we're going to be going over more in this video. So let's make this example slightly more generic and representative of a real world scenario. So let's say we wanted to print out all of the squares of numbers from 1 to 5. Well, firstly, we could start at setting a loop variable I equal to 1, and then constantly checking if I is less than or equal to 5 to only count numbers that are 5 or lower. And then this code inside the curly braces will be executed if this condition results in true. And then after this code is executed inside the curly braces, I will be updated by being incremented by 1, which is what this I++ does. However, we can also adjust it by some other number by doing I plus equals, and then instead of doing incrementing it by 1 every time, we could do 2, for example. So in this case, since we're incrementing by 2 every time, it would first go I equals 1, and then this code, and then not this code will run. Firstly, I is equal to 1, and then 1 is less than or equal to 5, so this code inside the curly braces can run, and then I changes from 1 to 3, and then 3 is less than or equal to 5, so this code runs again, and then I changes from 3 to 5, it's 3 plus 2, and then 5 is equal to 5, and then this code runs, and then I changes to 7, but 7 is no longer less than or equal to 5, so the loop ends. And so if we wanted to calculate the squares of all the numbers like we did earlier, we can use console.log to print out the values, and then we can say we're accessing the loop variable here, and then times I. And now if we run the code and look at the console, you can see 1 squared is 1, 3 squared, which is the next number in the sequence, is 9, and 5 squared, the next number, is 25. And I doesn't go further than 5 because of this condition that we've set. We can also change the increment back to 1 by changing it back to I++. And now you can more clearly see that the squares of all the integers from 1 to 5 are printed out. And the reason why this condition is especially important and the way that we update it is so that this condition eventually becomes false and the loop ends. An example is if we change I++ to I-, so 1 is subtracted from it every time instead of being added to it. And now you can see when I run the code endlessly loops. It's so endless that this console window isn't even updating here. So, and it's saying this page is slowing down Firefox. So you have to be really careful about how you update this loop variable and the condition that you're checking so that infinite loops like this don't happen. Another case when this could happen is when we accidentally use the wrong sign or the wrong comparison operator on this I variable. So for example, if we make it so that it only checks when I is greater than 0, then I will start at 1, and then this will be printed out, and it'll go to 2, and then this will be printed out again since 2 is greater than 0, and then it'll increment, and then it'll go to 3, and then this condition will always resolve to true, which means we'll enter an infinite loop once we run the code, which means this page will eventually stop responding and the browser will crash. However, to prevent infinite loops from happening, we can break out of it once the loop variable I reaches a certain point. And so the way we can do this is by using an if statement. And so we can check when I reaches 6, for example. And then when that happens, we can say break like this. This break statement basically breaks out of the loop, allowing the rest of the code after it to run. So if we run the code, you can see I keeps going from 1 to 5 here, but then once I reaches 6, then it breaks out of the loop without going and printing out 6 times 6. That's why you don't see 36 after 25 here. You only see the numbers 1, 4, 9, 16, 25. Because the square of 6 isn't printed out. It breaks before that can happen. Another useful thing to do in loops is to exit the current iteration of the loop early and then just go straight to updating the loop variable and then checking the condition and then running this code for the next one. This is called continuing a loop, and it can be achieved by using the continue statement. So as you can see, I've made it so that it checks if I is less than or equal to 7 to prevent it from going into an infinite loop. And so I've made it so that if I is equal to 6, then the continue statement runs, so that it basically skips the number 6. So as you can see, if we run the code, the squares of all the numbers from 1 to 7, apart from 6, are printed out. So continue can give you a pretty easy way to skip various values of I. This concludes episode 21 of the series. Thank you very much for watching, and make sure to look out for episode 22, where we'll be learning about more different types of loops.